All right, so we are going to do section 13.1, and we're doing this from the Algebra 2 book. All right, but it's trig. It's the stuff that we did in chapter 8. Okay, and so it should be very familiar to you. It's called trig functions in right triangles. Okay, so it's trig functions in right triangles. All right, so it's not law of sines, law of cosines. Okay, but it is sine, cosine, tangent. But it's a little bit more than that. That's the little bit extra that they have on this section than what we did in algebra or in geometry. So let's draw a right triangle. And let's just see if we remember any of this stuff. I hope you did. We spent quite a bit of time on this. There's a right triangle. And let's just call this theta, this angle right there. Okay? We talked about the names of the sides. We named the three sides when in reference to this angle right here. What about this side right here, this slanted side? What did we call that? Hypotenuse. How did you know it's the hypotenuse? It's across from the 90-degree angle. It's across from the right angle, opposite the right angle. So that's the hypotenuse. Now again, according to this angle right here, because this would be different if we're talking about this angle up top here, but I'm talking about this angle down in here. According to this angle right here, what is this side going to be called? This is opposite because it's opposite the angle. Okay, sometimes they'll call it the reference angle, whatever. Okay, when we're talking about this angle theta, this side is opposite angle theta. What about this side on the bottom? What do we call that? That's adjacent. Is it coming back to you now? All right. And we learned some trig functions. We're going to put that down here. So we learn what the sine of the angle is. We learn what the cosine of the angle is. Let me scoot this down a little bit. And we learn, what's the other one? The tangent of the angle. Now, there's three other ones. I think I mentioned it like real quick when we went over this in the first chapter, in chapter 8. I don't know if you remember this or not, but there's also inverse functions to the sine, the inverse. Well, actually, let's do this first, then we'll talk about the inverses. We learned a little way to remember what the sine of an angle is. Do you remember what that little device was? SOHCAHTOA. And what did that mean? What is the S? The sine, and that means it's the what? Opposite over the hypotenuse. So I'm going to put opposite over hypotenuse for the sine. The cosine is what over what? Right, it's the adjacent over the hypotenuse. And that's easy to remember from this little mnemonic device, SOHCAHTOA. And then the tangent would be OA. That would be opposite over adjacent. Middle school still playing sports? This late? Must be makeup games or something. Oh, it's somewhere else. Yeah, somebody said it was New Jersey. I'm like, why are they playing in New Jersey? Is it just a fun game or something? Just nationally ranked. Okay. All right. So that's our regular trig functions, our three basic trig functions. When you get higher in math, what we do is we have some functions that do the inverse of these trig functions. So we have an inverse of the sine function, and I'm going to write the word out. Then I'll show you the three-letter abbreviation for it. Okay. The inverse of the sine function would be called the cosecant. Do you remember me talking about this before? I did it real quick. We just mentioned it just briefly, I think. I don't know. Maybe we did, maybe we didn't. I thought we did. And here's the abbreviation for it. We just put CSC for cosecant of the angle. These are all inverses. Okay, these are all inverses. We'll talk about what that means in a second. Now, the inverse of the cosecant would be the secant. All right, and that would be just SEC. That's how we shorthand the secant. It's still a it's still a ratio between two sides of our right triangle here. And the inverse of the tangent is called the cotangent. All right, and we shorthand that just COT. Now, if I say they're inverses of each other, what do you think the secant is? Now, we don't have any fancy mnemonic device. I guess we could make one up, but we don't. We just know that the cosecant is the inverse of the sine. So what would the inverse of the sine function be? If the sine is the opposite over the hypotenuse, what do you think the inverse of that is? Exactly. It's the hypotenuse over the opposite. Does that make sense? Because they're inverses of each other. Okay, you flip the fraction. What about the secant? The secant is the inverse of the cosine. If the cosine is adjacent over hypotenuse, then the inverse would be hypotenuse over adjacent. You get the hang of that. That's not hard to understand, is it? And then the cotangent is the inverse of the tangent. Well, if the tangent's opposite over adjacent, what's the inverse of that? Adjacent over opposite. You with me on that? Now, there's no little device to remember this. The only thing that you really need to remember with the inverses, and this may look a little crazy looking, with all these different CSC and SEC and COTs and all that kind of thing. All you got to do is know which one is the inverse of the sine, which one's the inverse of the cosine, which one's the inverse of the tangent. The tangent, that's easy, isn't it? Right? Because that's got the word tangent in it, and this has the word tangent in it, so you know that they're inverses of each other. That's pretty easy. What about the sine and the cosecant, though? It doesn't make sense. A lot of people think, oh, the sine and the secant are inverses of each other, but they're not. Because why? They start with this. This isn't really why, but it's how can you remember? You can remember that they're not inverses of each other because they start with the same letter. All right? If they start with the same letter, in my head, I'm thinking, oh, they're not inverses of each other. They must start with something different. All right? So the sine is the inverse of the cosecant because one starts with an S, the other starts with a C. Does that make sense? And it kind of makes sense because I'm thinking, okay, they're inverses, so they must have different letters. They both must start with different letters. So the sine and the cosecant are inverses of each other, and the cosine and the secant. See, this one starts with C, this one starts with S. The cosine and the secant are inverses of each other. Again, a lot of students think, oh, sine and secant, cosine and cosecant. No, they are not inverses of each other. It's the sine and the cosecant. The ones that start with the different letters, they're the ones that are inverses of each other. That's how I remember it. It's not a fun little cute way like SOHCAHTOA, but it's the way that my mind thinks, and I'm thinking, okay, inverses, sine, cosecant. Cosine, what? Secant, okay? And then tangent and cotangent, that's pretty easy. We don't have to really think about that one too much because they both have the word tangent in it. Make sense? Okay. So what if they did this? We did this in the other class. What if, I don't even think they do this, to tell you the truth, but just play along. Okay, what if they said, oh, you know what I was going to do? Let's do this. Let's do an example first before I do what I was just going to do there. Where'd it go? Oops, I thought, oh, I didn't. Oh, what's that? Oh, I know what that's from. I copied something a while back. And let's just use the same triangle. There we go. Oops, missed that part, didn't I? I thought I did. I wasn't sure. That's good enough. All right, so here's our triangle. Let's put some numbers in here. In fact, let's just go real easy. Let's just go say 3, 4, 5. Okay? It is. It's Pythagorean Triple. All right, so let's just do this very quickly. Sine, cosine, tangent. All right, and let's just write out what the sine, cosine, and tangent is of theta. Here's theta, and this is a right triangle. And what's the sine? The sine is the opposite over the hypotenuse. So what's that going to be? 3. Come on, talk to me now. Help me out so I know you're alive. Over the hypotenuse? 5 is the hypotenuse. Okay, the sine is the hypotenuse. So the opposite over hypotenuse. That's the sine. Would you agree? This is all old stuff. What about the cosine? What's the cosine? It's adjacent over hypotenuse. What's the adjacent? 4 over 5. And the tangent is opposite over adjacent. So it's going to be 3 over 4. Pretty easy, isn't it? Yeah. What if they ask for the inverses of these? What's the inverse of the sine? Cosecant. Very good. It's the cosecant. All right. Now, what is the inverse? The cosecant is the inverse of the sine. So, if you think about it, it's just what? 5 over 3. Because instead of opposite over hypotenuse, this is going to be what? hypotenuse over opposite, correct? So here's hypotenuse, here's opposite. It's going to be 5 over 3. Does that make sense? So that's what the secant of the angle is. What's the inverse of the cosine? The secant. So it would be the secant of theta. Now again, it's the inverse of the cosine. The cosine is 4 over 5. So what's the inverse of 4 over 5? It's 5 over 4. Pretty easy, isn't it? Yeah, it's 3 different words, but really, is it any more difficult? Not really. And then what's the inverse of the tangent? The cotangent. Right, instead of 3 over 4, which is opposite over adjacent, it's going to be adjacent over opposite, which is 4 over 3. You with me? Okay. I don't think they do this in this lesson. This is what I was going to do just a minute ago. But what if they give you this and they say solve for theta? Well, this is what I would do. First of all, you should recognize what the cosecant is. What's the cosecant? It's the inverse of the sine. All right, so what would the sine of the angle be? It'd be 3 over 5, wouldn't it? Because they're inverses of each other, right? So the sine would be the inverse of this, so I could just make that 3 over 5. Now, could you actually find the angle?
Yeah.
How would you find the angle here? Take the what? The inverse, right? The inverse sine. Sine of the negative first. No. Good question. I don't really know. It's a great question. I don't think I can articulate an answer because I'm using inverse in 2 different ways, and I don't know if I could have a. I know exactly what you're thinking because I'm kind of thinking the same thing. I was just hoping nobody would ask me. I'm not sure how to articulate the difference between doing the inverse sine here and then the inverse of the sine of theta. So what I'm doing here, this is the inverse of the sine of theta. I think this might work. The cosecant is the inverse of the sine of theta. What I'm doing here is I'm just taking the inverse of the sine. I'm not taking the inverse of sine theta. I'm just taking the inverse of the sine and keeping theta by itself. I think that kind of explains it. I know it seems very subtle, but it's a big difference. Yes, sir.
If you were to find what they said, find the cosecant of theta, would you say cosecant of theta equals 5 over 3 and then
I would do this. This is what I would do. If they said solve for theta, right, and they gave you the cosine of the cosecant of theta is 5 over 3.
Would they ever say find the cosecant?
They could, yeah. Yeah, I mean, they could give you like a triangle like this and say, yeah, find the cosecant of theta. No, they usually want fractions. Yeah, they usually want fractions. Okay, so how would we go about doing this then? We would just hit turn it on first. Get rid of that. We'd hit what? Second function sine of 3 divided by 5, and then that's 36.9, right? So that would be 36.9 degrees. And that's, remember what I said? If the only thing they gave us was that, could you find the angle? Yes. So what do we have to do first? That we change it to sine, which we know is the inverse of the cosecant. Then we can solve for theta. So we don't go directly from the cosecant to trying to, do an inverse second function button on the calculator and getting an answer. Okay, don't crinkle up. It can wait. All right. Let's move on. That part right there, I don't even think they give that to you. That was just kind of free of charge, right? So it's not included in your tuition. You're welcome. All right. Let's see. Time. I think we got time to do this thing right here. I didn't do this in the last class, so this will be good that we get to do it in here. Yes, sir. I don't know. You can use any of them, any of the 6. But you're going to basically, here's a question Joe said. If you want to solve for theta here, can you use any of the 3? Absolutely. All right, you can use any of the 3. It's going to come out to the same exact thing. In fact, this is probably one of the reasons why it took a little longer, because we did this in the other class. Watch. We already did, let's do this again. Second function sine of, I'll do it quick, 3 divided by 5, and that's that number right there, okay? Let's find what theta is using the cosine. So what would you do? Second function cosine of 4 over 5, correct? Look at that. Same exact number. Doesn't matter which one you use. Let's do the tangent. So second function tangent of 3 over 4. Okay? And it should work out the same way. It's the same angle, right? So no matter which way you do it, you should get the same exact answer for theta. Right? It works either way. So you actually could do it any of the 3 ways. Even if you did it with the cosecant, you're basically taking it from the cosecant, turning it into the sine anyway, aren't you? And you're taking the secant and turning it into the cosine, taking the cotangent, turning it into the tangent. So you really only have 3 ways to do that. And you could use all 3 and you'll be fine. All right, let's do an example. Let's scooch this up a little bit right there. Let's see what they gave you. This is, now I know you don't have the book in front of you because it's Algebra 2 and I didn't give you the books, but take good notes on this, all right? I did ask to borrow it, yes. Watch this. The sine of angle B is 5 over 8. Now watch this question. Find the value of the tangent of angle B. Angle B is right here. You can't see angle B? All right. Here's angle B. It's this one right here. And I want to find the tangent of angle B. Well, first of all, how would I find the tangent of angle B? Here's the angle. What's the tangents? What over what? Opposite over adjacent. So what's the issue here? Finding A. I got to find the adjacent, don't I? So I could find adjacent. How could I find it? Okay. It says find the tangent of angle B. The fraction, correct. Not the actual angle. It doesn't say. If it wanted you to find the angle, it would say find angle B. But it doesn't. It says find the tangent of angle B. Remember, the tangent, sine, cosine, all those are just ratios. It's a fraction, right? It's something over something else. That's what they're asking for when they say find the tangent of an angle. Okay? If they wanted you to find the actual angle in degrees, they would say find the measure of angle whatever. But they don't ask you. They ask you to find the tangent of it. So we need this though, don't we? Yeah. How do I find that? Find this? I would do Pythagorean Theorem, right. You got 2 sides of a right triangle. Okay, the best way to do this is to find this. Okay, now you could have figured out what this angle was, I guess, and then taken the tangent of the angle, but then you wouldn't get an exact answer. You'd get decimal approximations. This way it's going to give you an exact answer. All right, I don't know if they even say give an exact answer, but we want it. We want an exact answer. So we got to find this. How do we find that? Well, yeah, so it's 8 squared what? Minus 5 squared, isn't it? Are you getting good at Pythagorean Theorem? You can just do that now. You don't have to write out the whole entire thing. Okay, and that equals what? A squared, right? So this is 64, what's that? Minus 25. What's that come out to be? 39. And that's a squared, so we find a. You take the square root, so a, no, we're not 6 point anything, okay? Keep it the square root of 39. I said I want an exact answer here, all right? So don't put it into a calculator, all right? I'm not snapping. I just said like 5 seconds ago that I wanted this exact answers, okay? Not a decimal. Don't be so quick to put stuff in decimal. Now, can we find the tangent of B? Opposite over adjacent, correct? 5 over what? Square root of 39. Right, but I don't want to leave it like that. We've talked about that on several occasions, haven't we? How do we get rid of that square root of 39? Multiply top and bottom by the square root of 39. Why are we allowed to do that? Yeah. The reason we're allowed to do this is because we're just multiplying by a 1, and that doesn't change the value of it, does it? All right, so I'm allowed to do that. And then what's our answer going to be? It's just going to be 5 times the square root of 39 over what? 39. So that's what the tangent of B is equal to. Once you get used to it, it's really not that bad. Okay? So that's the ratio. That's the ratio of the opposite side to the adjacent side on that particular triangle. when the opposite side is 5 and the hypotenuse is given as 8, that's the ratio of the of angle B. Yes, sir.
So basically, my question is, I'm going to overcomplicate why do we need this much. But if we're going to, let's say you want to be a carpenter. If they keep teaching us, you do Pythagorean Theorem and then your exact answer is square root of 39, why would we put it in a decimal so it's easier?
Probably would, but you probably would. But they want you to write it as an exact answer. We want an exact answer. There's a lot of reasons. I mean, listen to this. Think about the area and volume thing you just finished doing on that thing, right? Remember I said, round it to the nearest tenth, blah, 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 and all that kind of stuff. Some of you guys are taking stuff. Now, this doesn't have anything to do with tangent, but it's still the same principle. Some of you guys are taking values too early, rounding it, putting that into another answer, doing something to it, and rounding that, and then you're not going to get a very accurate answer. The thing is, what you want to do is you want to be able to, this is just real, super, super basic stuff. It's going to get way more complicated, right, in the future, calculus and all that. So what you want to do is you want to try to keep your answer as exact as possible for as long as possible till the very end. Then, at the very end, you can chuck it into a calculator and get an approximation. That'll be your most accurate approximation, okay? Everything they do, everything, building a bridge, building everything else, it's all approximations, but they're very, very, very close approximations, okay? And so what we're trying to do is trying to teach you to keep it exact as long as possible, because then in the end, this might be a 10-step problem. But if you round right here, and then you put it into something else, then you put that into something else, you put that into something else, and it keeps rounding, it gets less and less and less accurate, okay? So we're trying to keep things as accurate as possible for as long as possible. Does that make sense? Okay. Now, you bring up carpenters. Yeah, carpenters do use geometry. They do use math. But there are other occupations that go way beyond the math that's used just in carpentry and that would want this to be an exact answer for a very long time. Okay? So there we go. All right, we need to keep going quickly.
Okay. I'll ask you.
Okay, good. Let's take a look at this. You've seen this before in the same chapter that we did the trig stuff. It is a right triangle, but it's not just any old right triangle. It's an isosceles right triangle, which means what's true about the two angles? And they must be how many degrees? Doesn't depend which angles. 45. They're both 45. If these two sides are equal, remember opposite angles angles that are opposite equal sides are equal to each other. So they're equal to each other, and they have to add up to 90 because it's a right triangle, so they both have to be 45. So it's 45, 45. Remember, this is the hypotenuse, this is a leg, and this is a leg. This should be just refresher, but I know it's been several chapters, chapter 8, since we've done this. But this is important stuff. Hypotenuse is equal to, do you remember what the number was? Not 2. Square root of 2 times one of the legs. You don't remember that? Okay, there it is. That's why we're doing this. We're reviewing this stuff. So hopefully when you have this stuff next year, it'll be a little bit straighter in your head. All right, so know that. Let's do another one. Let's not take any questions because I'm running out of time and I need to finish this. We'll have time for questions tomorrow. Okay, I'm not trying to blow you off. It's just I want to get at least some of this done. Let's say that's 30 degrees down here. What's this angle have to be up here? It's got to be 60. Okay. Remember, we call this not just any leg. This is the short leg, and this is the long leg, and this is the hypotenuse. We had two relationships here, didn't we? Remember, what's the most important side? The one that I said was the short side. And the reason I make it the most important is because the hypotenuse relates directly to the short side, and the long side relates directly to the short side. Okay, that's why I think the short side is the most important one here. Do you remember the relationship with that? What is the hypotenuse compared to the short side? It's twice, right? Exactly double the short side. Remember that? And then the long side It's just a little bit smaller than 2. Remember, 2 is the square root of 4, isn't it? What's just a little bit smaller than the square root of 4? The square root of what? 3. Okay, that's how I remember it. I mean, I've been doing this long enough where I just remember it. But when I first started doing this, that's how I remembered it. Okay, the square root of 3 is just a little bit smaller than the square root of 4. I know the long side is just a little bit smaller than the hypotenuse, so it kind of makes a little bit of sense. Make sense? Okay. Now, let me do something real quick here. I only got a couple minutes. With all that said, you got that in your notes, right? Let's do this. What we're going to do is we're going to actually, without using a calculator, do you hear me? Without using a calculator, we're going to figure out what the sine, cosine, and tangent is of these special angles, like 45 degrees, 30 degrees, 60 degrees. Let me show you. What I'm going to do, and I'm not going to explain why, you can learn why later. I'm going to make the hypotenuse 1. You're probably thinking, well, why did you make the hypotenuse 1? Well, just don't worry about it. We can show you at some other point why the hypotenuse is 1. Now, we'll just call this x. We don't know what it is. And this is going to be what? If this is x, what's this going to be? Don't say y or z. It's going to be x as well. Why did I also call it x? Because they're exactly the same. I wouldn't give it a different letter, would I? Because they're exactly the same. Now, what I want to do is I want to solve for x. So let's do this quickly. If I wanted to solve for x, remember what our relationship is? Hypotenuse is the square root of 2 times one of the legs, or times x, correct? So what's the hypotenuse? Oops. Look at it. The hypotenuse is right there. It's 1. Okay, it's not 2x, it's 1. It's the number 1. So if I solve for x, because I made it 1. Remember I said, I made the hypotenuse 1. Don't worry about why I did. Just understand I made the hypotenuse 1. There's reasons you'll learn later. Okay, don't worry about it right now. I just made this 1. How would I solve for x? Divide by the square root of 2. Now, let's simplify that. It's what? Square root of 2 over 2. So that's what x is equal to. Now, here's what I'm getting at. Let's do this. Let's say we want to take the sine of 45 degrees and the cosine of 45 without using a calculator. I've not used a calculator yet on this. Okay? I use just stuff that I've learned before. The sine of 45 is what? What over what? Opposite over hypotenuse. Opposite over hypotenuse. So what's the opposite side? Square root of 2 over 2. Over what? 1. Well, what's the square root of 2 over 2 over 1? It's just the square root of 2 over 2, right? Dividing by 1 doesn't change the value. Is anybody still listening to me? It doesn't change the value of it. It's just the square root of 2 over 2. Watch this. I didn't use a calculator yet, did I? Let's see what the sine of 45 is. So the sine of 45 is that number right there. Okay, let's see what the square root of 2 over 2 is. Square root of 2 divided by 2. Now, here it comes. Drum roll, please. All right. There it is. Look at that. So would you agree that the sine of 45 is the same thing as the square root of 2 over 2? Absolutely. Look at the cosine. What's the cosine? The cosine is the adjacent over the hypotenuse. What's that going to give you? Same thing. Square root of 2 over 2 over 1, which is just the square root of 2 over 2. These are exact answers. These are exact. The 0.707 that I showed on the calculator was a approximation. It wasn't exact. What about the tangent of 45? Watch this. This is kind of cool. What's the tangent? Opposite over adjacent. So it's going to be square root of 2 over 2 over what? Square root of 2 over 2, which is equal to 1. Watch this. Before you go, watch this. The tangent of 45 should be what? Boom. There it is. Isn't that cool? Whoa. We'll do some more of this with 30, 60, 90, and then I'll give you a worksheet tomorrow. I was going to give it to you today. We just kind of ran short on time. So we'll do that tomorrow. So no homework. I'll give you a worksheet tomorrow to work on.